Ultraviolet light is incident onto a photocell with a potassium cathode as shown below. The threshold frequency of potassium is 5.548 times 10 to the exponent of 14 Hertz. Define the term threshold frequency. So this is the minimum frequency that is required in order for electrons to be ejected from a metal surface. 10.2. The maximum speed of an ejected photoelectron is that. So the speed is equals to 33 times 10 to 5 meters per second. And then calculate the wavelength of the ultraviolet light used. So we know that energy should be equals to the work function plus EK max. We know that this is HFO plus this is half the mass of electron V squared. This is HC all over lambda. This is Planck's constant. That's the speed of light. Lambda should be equals to 6.63 times 10 negative 34. The threshold frequency, we are given it as 5.548 times 10 to the exponent of 14 plus half the mass of electrons times 10 negative 31 multiplied by 5.33 times 10 to the exponent of 5 squared. Times 10 negative 34 multiplied by 5.548 times 10 exponent of 14. So I am getting 3.67824 times 10 negative 19 plus 5.33 times 10 exponent of 5 squared. Times 10 negative 19. So that's negative 19. And then this side I'm getting times 10 negative 34 multiplied by 3 times 10 exponent of 80. So I'm getting 1.989 times 10 negative 25 all over lambda. So this is 4.00 times 10 negative 7 meters. The photocell is now replaced by another photocell with the rubidium cathode. The maximum speed of the ejected photoelectron is 6 times 10 to the exponent of 5 meters per second when the same ultraviolet light is used. How does the work function of rubidium compare to that of potassium? Write only greater than smaller than or equals to. So it is smaller than. So now we just have to explain. So we know that energy should be equals to the work function plus EK max. E is given as H and frequency. So now we are still using the same ultraviolet light, which means the frequency does not change. If the frequency does not change, it means that E remains the same. But the speed here, we are told that it is higher. Okay. So if EK max goes up, so EK max goes up and then the energy remains the same, it means that WO is obliged to go down. Because remember, let's just use numbers. Let's just say the energy is 10. And then now I have initially, when I was using the potassium, okay, let's just do this. This is 10 for the potassium. It was 10, and then the speed here was 6. It means that the work function here was 4. Now I'm using rubidium. If my speed has gone up, to 7, but the energy is still the same, it is still 10. It means that if the speed goes up, the work function must go down to 3. Instead of it being a 4, it will be a 3. So that when I add the 2, I still get an energy of 10. So we will say for the same frequency, a higher speed leads to a higher kinetic energy, to a higher EK max. Thus, the work function is obliged to decrease.